Good day, students. Today, I want to consider energy with which an incident light falls on a metal surface and electrons are emitted from the metal surface. Okay, the first thing to do is to write down the parameters so that it give you idea the formula to use. Now, let's see. What is the energy with which an incident light of wavelength 10 raised to power minus 7 meters falls on a metal and electrons are emitted? Okay, now I want to know the energy. Use E to represent the energy. We are given the wavelength 10 raised to power minus 7 meters and okay, I are giving the speed to be 3.0 times 10 raised to power 8 meter per second, and also the Planck constant to be 6.63 times 10 raised to power minus 34 joule seconds. The formula for energy equals HF. Energy equals Planck constant multiplied by the frequency. Okay, but we don't have the frequency in the question, and don't forget that your speed equals frequency times the wavelength. Now your frequency equals c, the speed over the wavelength. You replace your frequency in the formula because you don't have frequency in the question, but you have the speed and the wavelength. You now have your energy equals h c over wavelengths. H Planck constant multiplied by the speed. Okay, you can see the speed given to us. Speed of the movement of the uh, electrons that are emitted. Okay, you can see what is the energy with which an incident light of wavelength is forced on the metal and electrons are emitted. Okay, now let's substitute our value. The Planck constant 6.63 times 10 raised to power minus 34 multiply what is our speed 3 times 10 raised to power 8 divided by wavelength 10 raised to power minus 7. Now let's take 10 raised to power minus 7 to the numerator. So now become uh, energy to be equals to 6.63 times 10 raised to power minus 34 times 3 times 10 raised to power 8 times 10 raised to power, this division is negative minus, in indices, this division stands as negative. When you are taking the 10 raised to power minus 7 up, that will be minus 7. It's turned to positive. Okay, this negative, this division stands as this negative. This 10 raised to power minus 7 will now go up to now turn to positive. Now it will be 6.63 times 10 raised to power minus 34 times 3 times 10 raised to power 8 times 10 raised to power 7, because negative and negative turn to positive. Your energy now, because let's multiply 6.63 times 3, 6.63 times 3 times, let's collect the like terms, times 10 raised to power minus 34 times 10 raised to power 8 times 10 raised to power 7. Now, it will be, let's multiply 6.63 times 3. 3 times 3, 9. 3 times 6, 18. 8 carry 1. 3 times 6, 18 plus 1, 19. Now, we now shift 2 times 1, 2, because of the two numbers after decimal. 1, 2. We shift 1 to count the two numbers 1, 2. Now shift 2 times 1, 2. Now it will be 19.89. Okay, now it will be 19.89 times 10 raised power minus 34. In indices, when you are picking one 10 to represent the tray 10, at the power or the index multiplication will turn to positive. Okay, minus 34 plus 8 plus 7. Now the energy to be 19.89 times 10 raised power minus 34 plus minus 34 plus 15. 8 plus 7 is 15 plus 15. Okay, let's do the subtraction. 34 minus 15 minus 34 plus 15. That's having 19 minus 19 minus 19. Okay, now it will be 19.89 times 10 raised power minus 19. Okay, now you want to shift. When you are shifting from the right to the left, you add plus 1 to the power, because positive, when you are moving from right to the left, shifting from right to the left, it will be positive. Addition of the power, go to 1.989 times 10 raised power minus 19 plus 1. Because I shifted one time, add plus 1 to this minus 19. Your energy now equals 1.989 times 10 raised power minus 19 plus 1, that is minus 18. Minus 18 joules. The unit of energy is in joule. That brings us to the end of the class. Please don't forget to subscribe for more updates, and also don't forget to leave your question in the comment section. Thanks for watching and have a wonderful day.